Today we're going to help make Chicago a safer place to live and work by modeling building violations in the city. If we can more accurately assess which buildings are more likely to fail inspections, then we can send inspectors to those places first, prioritize investigating them, saving time while we more efficiently allocate resources in the city. We're going to highlight two powerful features on Watson Data Platform. The first is Model Builder, a graphical tool you should use to build models in an automated and intuitive way. And next, we have performance monitoring and continuous learning, where you can easily tune and redeploy your models automatically as more data become available. We'll add data from September 2017 to our project from the sidebar here. And after we add it, it should appear here under our data assets, and we can inspect the data by giving it a click. This data is the September 2017 data from the City of Chicago, and it includes features like the bureau, the violation code, the property group, whether it's small, medium-sized, or large, important information about the location, like latitude and longitude. And what we're modeling is inspection status, that field all the way on the far left. After we're satisfied that this is the data we were looking for, we can go back to the main project user interface and add a new model to the project. We'll be able to use the data that we just added into the data assets to train our model. You'll need a valid machine learning instance from IBM Cloud and Spark Service in order to train and store your model. Next, we'll give it a name, something like Building Violations Chicago 2017 is good, and then we'll select Manual. You can also create models in notebooks and with SPSS Modeler, but we're using the Model Builder here. It's possible that you have a lot of data assets in a project, so we have this powerful search and filter functionality to find the data you're looking for that you'll use in the model. So we just type in BUI and we're able to find the buildings data. After we select the data and click Next, we're brought to the Model Builder homepage. On this screen, we can do things like choose the value we'd like to predict. That's our label column. We already know it's inspection status. Choose the features we're interested in, and we can add estimators. So those are the model types. The first one we chose is logistic regression, and the next is a decision tree classifier. Both of these estimators are available for the problem we have at hand, which is a binary classification task. We're predicting whether or not a building will pass or fail an inspection. After we're satisfied with the setup, we click Next, and the Model Builder will begin training. Model Builder's capability to simultaneously train and compare models is great for more technical users. This way, you can explore different hyperparameters, compare algorithms, and choose just that model that's best for your task. Model Builder saves time for your data scientists and your analysts who can focus on solving the problem instead of configuring experiments and copying and pasting boilerplate code to compare metrics between models and explore rich hyperparameter spaces. Both models performed excellently, so we'll choose logistic regression and we'll save that model. Clicking Save will store this model in your Watson Machine Learning repository, which means it'll be available to you or anyone who has access to this repo. You can do things like expose the model as an API, or configure it for performance monitoring and continuous learning, which is what we'll do now. Every saved model has a page with information about the model. You can see here in the summary, the label column, the latest version of the model, the runtime environment, and even details about how the model was built in Model Builder, some other models we compared it to, and so on. Another thing that's really cool is the input schema. So you have this tabular view here where you can see the column and the data type, but we also have JSON representation of the input schema that's targeted towards developers. You can take this and drop it in an application or drop it in a script and take advantage of the Watson Machine Learning repo functionality to programmatically interact with your models. The story doesn't end after you save a model. Typically, just building and saving a model is not enough for solving a data science problem. You've also got to evaluate the performance of the model over time, create deployments, and expose your model for consumption in applications and analytics tools. For all of this, we have evaluation, continuous learning, and performance monitoring on Watson Data Platform. Continuous learning and performance monitoring offer more than just information about your model. We also offer the capability to retune, train, and redeploy your model after some trigger event has occurred. For example, suppose that the area under the ROC curve, a measure of performance of the model, starts to drift down over time. What we can do is say, conditionally, if the performance of the model decreases below 80%, then take all the new data, retrain my model, and redeploy the model for me automatically. And now, all of your applications and tools that depend on this model are updated. Continuous learning depends on a database table that contains the new information we'll need to learn from, the information that our model will use to retrain itself over time. Currently, we support IBM DB2 Warehouse on Cloud, so you'll need that service in IBM Cloud for everything to work smoothly. So you can create a new connection from that tab, or you can select your feedback data from a connection that you already have on Watson Data Platform. Here we'll navigate through our database and choose a table and click Select. A convenient and time-saving tool is the automatic creation of a new database table with the appropriate schema for your model. If you just enter a new name in that field there, New 2017 Table, then Watson Data Platform will automatically create a table in your database that has the right specifications for performance monitoring. And those final two menus are those conditional statements we spoke about a little bit earlier, which tells the system when you would like to retrain or redeploy your model. For example, when the model performance falls below a specified threshold. Now that we've configured performance monitoring for the first time, you can see that the evaluation screen has changed to reflect the decisions that we've made. We've got information like the model version, other specifications about the performance, when the last evaluation occurred, and so on. Now suppose that September has passed and we've got the October data handy. You can just drag and drop that data set after clicking Add Feedback Data and trigger a new evaluation. Triggering a new evaluation will read that data from the database table we specified earlier, evaluate the performance of the model, and then follow whatever conditions you specified. If that means retraining, redeployment, or just creating a new version of the model so you can compare the two iterations yourself. Although we do this graphically here, you also can configure performance monitoring and continuous learning entirely through a set of APIs that we've made available for developers on the platform. Now that we've added the October data, we see that the model's performance has actually drifted below this threshold we specified, which was 0.8. So we retrained the model and we redeployed the new model. You can see here under completion status the result of this training, and that was new version deployed. Now we can add even more data. So suppose that we want to add the November or December data. You could do that as well. And scrolling down, you'll be able to see each time a new version of the model is created. So let's try this out for ourselves. We'll add more data, navigate to November, and a familiar process will follow. Each time you trigger a new training or save another version of that model, Watson Machine Learning will make that version available to you for inspection, deployment, comparison, or consumption in a notebook. What this does is it allows you to pit different versions of models against one another to find the version that best describes your data and does the best job solving your problem. In our case, the model performed excellently to begin with, but you can see that over time, as the structure of the underlying data set changes with new and more complex examples, our model starts to become somewhat stale and the performance drifts down over time. That's all right, because we've got continuous learning that'll help us develop the best model for all of the data based on what we have available. Now that we've built the model in the model builder and inspected it in the overview page, gone through the evaluation and configured continuous learning and performance monitoring, we'll finally focus on deployments. What the deployments functionality does with Watson Machine Learning is it'll create an API endpoint. You'll be able to expose your model as an API and do things like online prediction with REST API calls, or batch prediction, or real-time streaming predictions. In our example, we'll just create a simple web service, which would be an API endpoint, and we can shoot over some data and get predictions back quite easily. Creating a deployment is as easy as clicking Add Deployment, giving your deployment a name, and that's it. Just like other assets on Watson Data Platform, if you click the asset, you'll be brought to an overview page that'll give you information about its status, when it was created, last modified, implementation details. Again, we've got a lot of resources targeted towards developers. If you go down to code snippets, you can see that we have resources for interacting with your model with curl or Java, JavaScript, Python, and Scala. In this way, we have more code that'll minimize the time it takes to cash in on your development work and begin making use of your models, to minimize the time it takes from developing models in the lab and in the notebook to getting them into a production environment where they can drive value for your team. Finally, we've got the test functionality where you can experiment with the features to get a better idea about how your model might perform once you deploy it. Now that we've created this deployment, let's go back to our models overview page or the evaluation tab and take a look at the versions at the bottom. Scrolling down, we'll see the best version of the model, which model is deployed, other information about the version, such as those metrics we choose to track, whether they're accuracy, the area under the precision recall curve, the ROC curve, and so on. You can also choose which model you'd like to use. This way, you can easily conduct experiments with different model types and different model versions without having to change or refactor the code that you already have in production. So this is a pretty powerful feature on Watson Data Platform. I encourage everyone to start a project, make a model, and enjoy exploring.